Okay, thank you. Thank you all for coming. And I'm very excited about this topic I'm going to talk about. So I hope that you are too. And well, during lunch, I was talking to Dr. Moore that was sitting next to me about plagiarism. And then actually what I have here, I stole from some of the places that let there be light, and that was light. I should have referenced that. It was from the Bible. But I didn't, so I apologize. And there was originally, God created light. You have sunlight. We all have sunlight. We still have sunlight, although today we don't have much today. And then we want more light. Then we have fire. Then we got light from fire. And then later on, then we invented candles and lamps. And that's where we get our light from. And then from fire to lamp, I think it went for, I don't know how many thousands of years. And then from the lamps to the light bulb that Edison invented, I think that was in the 19th century. So we had this for another, I don't know, a couple thousand years or hundreds of years. And then we have been using the light bulb for over 100 years. And then there's a fluorescence light that come along that's supposed to save us some energy in terms of electricity. But then we have been using this for a long, long time. So only in recent years, and then we are trying to use what we have been using in our laptop, in all the electronics, in using semiconductors. And that can also give us light. So this is the LED that you are going to see, going to replace all this regular light that you're seeing now. And then, of course, there's a laser, including this laser pointer that I'm using. And well, this is not exactly semiconductor, the green one. But all the other, the red one, those are semiconductors also. So we have gone through this evolution of light in thousands of years. But every time, it takes some time. But we hope this latest one, switching to semiconductors to LED, is going to be much quicker because we really need it to save energy. So this is what you probably have seen around you, that how LEDs light up our lives. So this is like in the display windows. People have been using that for, I know, over 10 years. For decoration. And then there's a NASDAQ billboard. It was built with 1.9 million LEDs, and that was in the late 90s. And it cost a lot of money. So you can see this index here, and now it's 1,000 points higher. This is 1829. This was the NASDAQ index, I don't know, maybe 10 years ago. So I have this LED that light up your pocketbooks, literally light up your pocketbooks in the display windows. So if this goes down like this, it also light up your pocketbook if you have a lot of NASDAQ stocks. And this is the LED. You can use it in indoor. You can use it as a mood light. And you can use it to lift your mood. And for the suntan, this is a violet LED. And also now a lot of the cars, instead of using the lamps, and you also find the LEDs are in the installed in the cars. And this has been going on probably for at least 15 years, particularly the cars. The red one, the stoplight, that was the first one that changed over because the LED is an electronic device. It's a response really, really quick. You step on the brake and then you save, like it will light up in split seconds. So the regular lamp does not do that. And the fluorescence lamp, you know, some of the fluorescence lamp that's not that great to turn it on. It takes a few minutes before like, it gives you the amount of light that you want. So this, the LED has been slowly but surely is replacing many of our light sources. So these are your familiar. These are what you see at night in Hong Kong. So there's a New World buildings. And these are the Canon buildings. And then you see this changing colors. And there's AIA. I think this must be LED. And then there's Eiffel Towers. So these are the architectural lighting that people have been using the LED to make all kinds of different displays. Of course, there used to be neon lights that you will see, but the neon light is very expensive, and it also uses a lot of electricity, and much, much more than the LED that we're talking about now. The LED, little tiny semiconductor chips. And I can show you, I can even run on mobile device. I actually have a couple samples here that we make in our lab that we can make the display that you can see that run on batteries. It can run for a long time. So this is what recently people are doing now, is using the LED for illumination. So the early one that I talk about is mainly indication, architectural lighting, decoration. But now we're talking about from decoration to illumination. And this is a big, big step that we want to have the LED give you enough light to replace this one here. All these are the very recent installations around the world. And then this one is a gas station in Beaverton in Oregon. And then this is the Munich airport. And then these are the high-pressure sodium lamps that you see in parking lots, a lot of the places. And now people are replacing them with the LEDs. And then the Hong Kong Airport Authorities has a lot of LED lamps. And you can ask Mr. Tong about it. He's sitting here. And then they are one of the really forefront showcase of LED lighting. And then these are many of the street lights around the world. They're also trying to replace it with the LED. Of course, there are many of them are not very well made. So you might see some of them, the color rendering index might not be very good. Actually, there was one time I was in a parking lot. It was in California. And I had a rental car. It was I think it was a red or maroon color rental car. And then I parked it and went in for dinner. When I came out to the parking lot, I couldn't find my car. And then because the color rendering index of, I think it's probably not LED, probably a high-pressure sodium lamp. And the color, it's actually a kind of dark gray instead of red. So I was looking, and this is not the car that I rented. But that is, we're talking about the color rendering index of your light source. If it does not have a good color rendering index, when it shines on whatever object that you're looking at, it's not the original color. So this is what we use to designate how good that your light source is representing the sunlight. We call it the color rendering index. And then this is a bridge in Guangzhou, and you can see it's changing color. There are many of these around now. It's really beautiful. And then a lot of the integrating this solar power street light. So during the day, it can absorb the solar power, and then at night, then it can light up itself. So this is in Hong Kong, back to Hong Kong. And then when I first came back to Hong Kong in the year 2000, and then I look around, and then some cities already changed the traffic light. This is the first use of the LED, is the traffic light. And then in Hong Kong, there was essentially none, zero. And in Taiwan, there's some. In Singapore, there's some. In the States, many of them just change the red color. And I'll tell you the detail if you want to know why. And anyway, in Hong Kong, it was only in the 2004, and in the Hong Kong government is to start using the LED as trial use, they call it, trial use. But now if you look around, it's almost 80% of the LED lights. Of the traffic light, they are LEDs now. They are all LEDs. So this is, I have this little figure here. It's, a lot of people, they don't think out of the box. And I said, this is the thing, you need to think out of the bulk. So you don't have to use a light bulb as your light source. And you can have the semiconductor as a light source. So this is chart here is I'm trying to show you a comparison of the cost of ownership of the different light sources, the incandescent, the light bulb, the halogen, also light bulb, the fluorescent, and the LED. So I call this a comparison, the cost of ownership comparison. I call it LEDonomics. Okay, I didn't steal it from anyone. I invented this word. It's the economics of a LED. So what I'm comparing here is the initial cost for you to buy a roughly might be a 60 watt or 75 watt incandescent light bulb that will give you 800 lumens. This is the amount of light that you see from the light bulb. So it might cost you around $8. And then for halogen lamp, it's more expensive. And then for the fluorescence, there's a wide range. And then for the LED, that will give you this amount is around $150. A lot of my colleagues challenge me about this cost. They say, well, the really good ones, it will cost you $350. Well, I say, yeah, because now there's a really wide range of quality and wide range of prices that you see. And this is not settled down yet. I just give some kind of average price here. And these are actually good ones. And then the lifetime of these light sources, and for the LED one, you can use it for 50,000 hours. And then for the lifetime of incandescent, you have to replace for 50,000 hours. You have to replace 50 times. And then this will be the cost if you replace 50 light bulbs. And then for the halogen, it's a longer lifetime, so you can you only replace it 25 times. And then the fluorescence is also longer lifetime. You only replace it 5 to 8 times for 50,000 hours. And then now we talk about the electricity cost that you save over the electricity cost you use to give you this amount of light over 50,000 hours. Because of the incandescent, it's very inefficient. For each electrical watt that you put in there, it only gives you 11 lumens. And for halogen, it's a little bit better, 14. For fluorescence, it's quite a bit better, 3 times better, about 53. But for LED, it's twice of the fluorescence and almost 10 times of incandescent. So if you calculate that if you run your light source for 50,000 hours, that you have to pay $3,000 if you use a light bulb. And then you only need to pay $320. I'm using about 1 kilowatt hour, $1 per kilowatt hour. That's the electricity cost. And then the maintenance cost, and then if, okay, I don't know how you want to count your own labor power at home, so I just estimate some maintenance costs like the traffic light or some, like you need to hire somebody to replace the light. So there's the labor cost that you need to change it like 50 times or 25 times or 5, 6 times. So they just give a number there. So you add up all this like cost of how much you pay, and then how much electricity you need to run your light source, and then the replacement cost and so on. So this is your total cost of ownership for 50,000 hours of 800 lumens of light that you get. And then you can see if you use a light bulb, you don't change it, it will cost you almost $5,000. You use a LED, and it's only 10% of the cost. So you need to consider is the total cost of ownership, but not just the initial cost of buying the light bulb. And of course, a lot of people are also like challenging me that said, yeah, you said 50,000 hours, and then I bought an LED lamp, and then they only run for 500 hours, even shorter lifetime than the incandescent light bulb. That's true, because a lot of the lousy products are out there, and they are not well made. A lot of the time, it's just what is around it, like some of the like bonding wire and things that can be broken. So it's just not good quality control. But if you have a good one, it can endure, it lasts for 50,000 hours. So this is the cost that I just looked up in the internet from the Home Depot, and for an LED lamp. And then this one is, you might call this, it's a tapai for, it's called $18. This is US dollars. And then for this from Philips, and this is $25. And they said they already cut cost. And these are the light bulbs that can give you a certain amount of light that can replace a 75 watt light bulb replacement. And then some of them, they don't want to claim 50,000 hours. They just say 25,000 hours. And then these light, they are actually not that efficient. It's only 65 lumens per watt. If you calculate how many watt, this is the input power, the wattage, and how many lumens that you're getting, and then you can easily calculate the lumens per watt. This is the best light bulb you can buy now. And even though the LEDs can give you 100 lumens per watt, but when they turn into light products, it's only 65 lumens per watt. And then also they are quite heavy. It's over 6 ounces, and then it's 176 grams. So I'm giving you a little preview of what we are doing in the lab. And this is what I call it is N high, N low, and no LED light bulb. This is what we make in our lab. And what is high is a high brightness. You get a lot of lumens. And my student is here. He's involved in making it. And there's high efficacy. The lumens per watt that we get is about 82 lumens per watt. And then it's a high CRI. Well, now what we get is not very high, but this is what everybody's aiming at, the color rendering index I was talking about earlier. And then it's a long lifetime, a really long lifetime. And then what is the N low that we're looking for is a low weight. The one that I was talking about is a 6 ounce, 170 grams. You put in your hand, it's really heavy. And then here we're talking about less 20 grams. And then it's a low heat. You don't see it, you don't get a lot of heat from this light bulb. And you don't use a lot of materials for it. It's really light. It's less than 20 grams. And the low form factor is really tiny. And also it doesn't use a lot of electricity because of the high efficiency or efficacy that we call. And also it's a very low degradation. A lot of the sources that over time you see the amount of light you're getting is going down. But this is the degradation is almost no degradation, but slowly, very slowly. And then it has no mercury. And the fluorescence light, you know, there's a mercury in there. And then if everybody passed the law, outlaw the incandescent light bulb, changing to all fluorescence. And then when we dispose all this fluorescence light into our landfill, and over the years, our groundwater will be tainted with mercury. Because even though for each of them, there are tiny little bit of mercury in there, that's all you need to give you the light. But if they are replacing the only light source that everybody's using, is going to be a problem. But for the LED, so it's there's no mercury in there. It's a little tiny semiconductor chip, and there's no organic. This is I just make fun with my colleague because people are making organic LEDs, and they are very expensive. I said, so we have no organic. So like when you go to the supermarket, when you buy anything organic, it's expensive. So we have no organic, so this is inexpensive. And there's no ballast. Like all the fluorescence light, you need a ballast to turn it on to control it. We don't need a ballast. And there's no time delay, so you turn it on instantly. So with this, all these goodies about the LEDs, so now you can design a little pillbox light, and this is actually a light, a Toshiba light, or a desk lamp. Because of a small form factor, you can put it any way you want it. So it can give you a slimline or streamline lighting design. So I know we have some designer here. I bet that they are designing with a lot more freedom with the LED as a light source. So now this is what we call, like I work in semiconductors. For those of you, if you heard about the Moore's law about the semiconductor chips, so this is how like the cost goes down over the years. And then with the speed of the LED or the transistor that will go up over the years. So what this is the equivalent for the LED, how the cost of the LED goes down over the years from the 1970s, and then how is the amount of light that you get from the LED, how it goes up in the years. And then how the shape of the LED change and the color of the LED change. So at the beginning, you only get the red one, just like those you see in the bus, in the elevators. And then later on, we have the yellow ones, and then the blue ones that came in the early 1990s. And this is actually the major breakthrough when we start having the blue one, because now you have all the colors, the blue one, green one, and the red one. So when you mix the colors, particularly with the blue one, that you can get white. The white color is what gives you the source that we can use to replace the lamp. And then this is, and with the amount of light that we can get from the LED, all different, the technology has been improving extremely fast. And that's why that we are going to have all the light replaced by LED in a few years. So what do we do? In our lab, this PTC, this is our logo. It's Photonic Technology Center. So I just talk about the few of the projects that we do. And one of the, I called it this LED on silicon. So it's something you can pronounce. It's a LEDoS, and then translated to Chinese. It's a 领导技术. So this is something has a little touch to it. And what we do here, we try to make the LED more cost-effective in manufacturing, combined with the silicon technology. And we're making micro display with it. And then I have a couple demo here that you can look at. And I'm also working with some of my colleagues who work on communications. Like Professor Ben Latave mentioned the Wi-Fi that everybody are using now. So we are working on the Light-Fi. So it's a light fidelity. So the Wi-Fi came from Hi-Fi. So and then now we have this Light-Fi. So it's essentially we use the LED, the visible light, as the communication tool, instead of using the electromagnetic waves. So this can be done also. So one of the grand challenges that we do in our lab is trying to put the LED on silicon. So I'm not going to go into detail of this. This is a lot of material science in it. So we have projects that's supported by RGC and also ITF. I've been getting very, very good support from this government agencies since I moved to Hong Kong. And that's why we can make a lot of these new inventions and a big leap forward with this support from HKUST and also the RGC and ITF. So one of the things that we're trying to do is that we're trying to grow this LED on the silicon. As you know, silicon is a substrate that you make all your IC on, and they are dirt cheap. And then the technology is also improving very fast, and the costs keep coming down, just like the Moore's law I was talking about. So that's one of the things that we are doing. So I'm not going to details in here. And other things that we're trying to do is trying to make the display with it. So now you see, when you go to all these stores, they said you're selling LED TV. They're not LED that you are seeing. It's a display. It's a LCD, liquid crystal display. It's only the LED is the backlight, because the LCD does not give any light. So need a backlight. So what they call LED TV is actually a LED backlight, LCD television. But what we have here is a small one. It's not a TV, but it's a real LED. It's a self-emitting. And then these, the LED display that you are seeing, like in Times Square or many of the places, including the NASDAQ billboard, and these are real LEDs that you're seeing. So you can watch a movie in the bright daylight, and this is because of the LED. But now each of these LED is individually packaged LED. So this is, I call it, it's like compared with the transistors. That is the transistor in the 1950s. And what we are trying to do is try to integrate and try to make LED like integrated circuits, like the ICs. And then this is the optical communications that people have been doing with the fiber, with the laser light. So I was talking about this light fire. They use the LED to do optical communication, but you don't need a fiber. It's in free space. And you can also call it fiberless light communication, optical communication. So this is some of the current display technology, including this projector here. It's, you use a 3 LCD, or this one here is actually a digital light processor that you are seeing. It uses millions of tiny mirrors that is directing the light. It has a big light bulb and then the color wheel, and this is what you're seeing as a projector. And these has a lot of problems, like the optical loss with the optical components is over 90%. And then this is a very expensive with the laser and also the rainbow effect. I'm not going to do the technical detail of this. And then there are the newer display technology. There's LEDoS, that is a liquid crystal on silicon, and the scanning mirrors. And these are the people are using it to either make the projection or the Pico projector. Is most of them are used the LEDoS, or using this scanning mirror lasers. It's a similar technology like the previous one. Again, because of the optical components, you got to go through the color filters or go through the polarization plates, and then you will lose 60% of the light. So what we're trying to do here is use the LED that you can see directly, and then we integrate it with the AM substrate. It's an active matrix, and this is made with the silicon IC. So when you combine this, that we created this LEDoS chip, and then you can have this micro display technology that we developed in our lab, and also this demo that you'll be seeing. So the idea is relatively simple. We have the LED array, and then after we make the LED, we flip it on the silicon chip. And then this is the LED array that, that you see here. And this is the technical detail, and you're probably not interested how we make it. And it's similar to people are making the LEDs, but then we leave individual pixel on the same chip. Then when you make it, so after you make it, and then we have this array of the LEDs. And the size of the array, you can change it to any size that you want. And then we have this silicon IC that we make the active matrix. It's 2 transistor, 1 capacitor, essentially. And this is a 30 by 30 LEDoS chips. That means it has 900 pixels. And then this one is 60 by 60 LEDoS chip. It has 3600 pixels. And then these are the size that between the pixels. So this is what the different generations. The first generation, we just make the 8 by 8 array, and then we try to put the color conversion material on it, so to make it full color. And then this is a 60 and 60 array, and then this is one that we have the UST logo. And then there's a HKUST that you can, and then this one we try to project it onto a wall, so you can, because we don't have the optical loss. So after the projection, then you will still see like 90% of the light. And then this is our future work that we try to integrate it with the other silicon components, including the power. So we try to put the passive power on the silicon chip that make the LED is have an increase in functionality and also make it even smaller. So this is our future work. So we can also make the intelligent light bulb. So I call it the iLight. The I stands for intelligent. So the Apple products, I this, I that. The I doesn't mean anything. And then this is our iLight. It actually means intelligent. So we try to make the light bulb intelligent and small. And then it's also the form factor is small, and also you get a lot of use out of it other than lighting. So this is the micro display that I already talked about. And also the light bulb is a light source and also intelligent. And you can like put intelligence into it. Like for example, if there's a lot of sunlight today, it's very bright, and then the light over there, it will have the sensor that it can turn down the amount of light, because all these electronic products, we can integrate them. And then back here, you don't have a lot of sunlight, and then it would turn up, so the whole room will have the same amount of light. And then this is the one that I was talking about earlier. We can use a visible light for communication. And then a lot of people ask, what's wrong with Wi-Fi? Nothing wrong with Wi-Fi, but then you need to install the Wi-Fi. Now we have the light there. It's already installed. It's already there. So why don't we just use it to do something else? Like in the supermarket, then if the light's already there, then we can use this light to beam the information to the shopping cart. So when you get by, it can tell you, hey, this is on sale. And then this product is have a certain information that you can find. And then in the car, the traffic light can also beam information and communicate with the cars, the oncoming traffic. And you can like sense this, hey, there's a lot of pollution out there. And then you can tell there's the people that drive by. So this is what we're going to use this light fire for. So this is a comparison of the display technology of our LEDoS display compared with the LEDoS. All of them, they are based on, will need a very high power backlight. So the LEDoS will have this backlight here. This also this digital light processor is also need a backlight, and then the LCD also need a backlight. So our advantage is you can see it directly, and it doesn't need a backlight. And also, you must all have the experience that when you have a digital camera, when you take out, you want to take a picture under the sunlight, and then you look at it like this. Another one of our students says, you want to share it. Otherwise, you don't see what's the picture you're trying to take in the little display. So with the LED, you won't have the problem, just like you can see movies in the sunlight in Times Square during the daytime, because you see the light emitting directly. And then also for the heads-up display in the car, so you can put it up there and then get all the information on map and whatnot. So this is a little display that we have that it can show you HKUST and also maybe our logo later. And then this is another one of our concepts that's think of the bulk concept. I mean, for the traffic lights, it's always 3 colors. But why do you always need 3 colors? So we said, why don't you just have a single traffic light there? And then the source will be our intelligent LEDoS chip. And then all you need is a little projection lens, because you don't need to project it very big, about this size, 8 inch. That's all you need. And then we can just cycle through it. Okay, when there's a walking, we show this. And there's yellow light, how many seconds is changing, and then stop is like this. This is for the pedestrian, and these are for the cars. So it will save you 1/3 of the material. And then using the LED, a single chip would do it. And then you can program it and just do this simple test. It's very simple. And then here, if you have this traffic light in the heavy traffic area in Causeway Bay or Mount Cobb, and then we can also integrate it with a sensor, and then it can sense this pollution, what's the API today, and then we can display it, and or somebody can come by and take the data. So this is the visible light communication will come in together and have this integrated usage of the traffic light. And then this is our LEDoS invention. It's an award-winning invention. The last year, we entered this HKUST. It's right here in this room. And it's an entrepreneurship competition. We won the 2nd place. And some of these, was Tony Chan, and these are students that are joining the team. So this is our award-winning LEDoS. And this is my team at the HKUST. It's the students and postdocs that are working in my lab. And then this is, again, this is a plagiarism from the lyrics of a song. It's You Light Up My Life, and this is LED Light Up Our Lives. Thank you.
Wow, this is another one of those possibilities that can really change our life again. I promise everybody that you can leave this place by 2:15, so we got 20 minutes for questionings. You know, if you would like to have more and more clarification on this. Before I say this, there's a gentleman here who was probably responsible for one of the largest LED lighting in the world. Henry Chen. Henry works with the Jockey Club of Hong Kong.
Yes,
and,
it's the first biggest billboard. Yeah, many years ago.
Yeah. So, maybe Henry, you want to share with us how did you started out with all these LED lighting things with the Jockey Club?
When the Starting Race Course was built in 1978, there was a suggestion that we should put a large outdoor display device so that the spectators in the grandstand can watch the race better. So we searched around the world at that time, and we located a factory or a company in Chicago that would make the a large outdoor display board. At that time, they used the very low voltage light bulb, which can only give 16 shades of image. And quite honestly, when we look back, it wasn't really showing a good picture at all. Then after that, we changed we upgraded to a Mitsubishi color board, and they use cathode tubes. I think they use four tubes to make out 1 pixel, and because it's controlled by electronics, then you get better, a very bright and very clear picture. And these days, I think the one that we have now at the 2 race course are the 3rd or 4th generation. And the LEDs, we are now using LEDs, and they are much smaller, and they are much brighter, and they give less heat and use less power. I still remember the first first display board we had in 1978. At the back of the board, we have to have huge fans for the ventilation to cool the light bulb down. And as a result of the light, as a result of the airflow, we have created a lot of dust on the surface of the tube, and we have to clean that after each race meeting. And at that time, the cleaning those boards is a huge task because we didn't have the right detection, and it would damage the light bulb and all that. So I think we have experienced the whole journey from '78 about display devices, and I'm glad to hear that it's we have a new era to coming in front of us, and I really look forward to seeing other application of those LED devices. Thank you.
Henry, would you consider having the Jockey Club commission, the UST, to do the research for you in the future, and then have a company here in Hong Kong to manufacture this kind of a screen, so that we can be the lead? I mean, this is something. This is something really extraordinary that we can happen here in Hong Kong.
As you know, I am only responsible for certain operation of the Jockey Club, which is the betting operation. Regarding the other applications and other operations, I can certainly refer you to our colleagues.
I'm just joking about this, but this is what we're trying to do, trying to make the connectivity all works like LED that lights us.
I certainly can help.
I think one of the important aspects, because horse racing is during the daytime, so that's why they need to have a very clear, bright enough that you show during the daytime. Only LED can do that. That you can watch, like I said, it's watch TV outdoor at daytime under the sunlight. No other display.
Well, one of the things that I was trying to say is a lot of these great inventions, great products are usually done by demand-driven rather than by supply-driven. If the demand warrants it, I mean, a small place like in Hong Kong, but we have a jockey club and we needed that for our customers.
Yes.
I mean, this is how it will happen. But
I bet they pay a fortune for it because one of the largest and earliest billboard that
we did.
Yeah. And then we also joke about it better be reliable because if they show like the betting amount on it, what if the dot is missing? Then instead of like giving people $180.85 is $18,800.50. It can be 2 orders of magnitude difference. That's a joke we were talking about.
Well, let's get back to a bit more serious. Any questions that you wish to clarify from Professor?
Well, thank you very much for a fascinating talk. The business minds, of course, keep spinning, and also the green minds, because obviously this is going to save a lot of CO2.
Yes.
Now,
no carbon.
my question would be, Professor Lau, when you look ahead the next 20 years, and of course we saw that the LED light source in the long run cost a tenth. I think that was the message.
The cost of ownership.
Our cost of ownership. Of course, that requires that one really sits down and looks at the overall cost picture. In Hong Kong, for instance, we're still driven by the cheapest solutions for buildings because there's very expensive land here, obviously, and we do have comparatively few government standards that tell us how to use energy properly. I think my...
Another one.
No? That's not an LED one. I'll be short. Can you hear me? Just in short, would you suggest that LED technology becomes part of the forward-looking government initiative for light sources in, say, public building? I'm looking at all these nice fluorescent ceilings here. There's a lot to be done in Hong Kong, but I'm afraid it only gets done by a few informed and high-quality oriented builders. And that the bulk of our consumption will still be on the non-CO2 friendly part.
Yes, yes. Well, you're right. It's a start from the government. So that's why actually the Hong Kong government has a consultation of the first step is the outlaw that inefficient incandescent light bulb. So there's many countries already did that a few years ago, and then Hong Kong have a consultation. I don't know what's they start doing it. So you cannot buy this incandescent light bulb. And then for the fluorescence one, I think because a lot of people have already changed to the compact fluorescence, and then for that to change to LED, like you said, we need to start from the public buildings. First is the government in the government buildings, and also the builders that will have this initial installation, because the initial installation is a lot less expensive than retrofitting. And then the last is to get into the individual household. Then we need to educate people that really the cost of ownership, that the amount of energy that you save is it's really worth it. Another thing that probably government cannot do is the business people who are making this LED lamps have a better quality products out there. Because a lot of these low quality products, yeah, some of them are low cost, some of them actually high cost and low quality. And they give people the wrong impression that hey, you told me this LED can last for 50,000 hours. It's only 500 hours. So we need to be know how to select these products and then weed out the bad ones. I think that's going to take time.
Just following up on what the previous speaker said, the problem that we have in Hong Kong, if you look at 50,000 hours, if we have a small shop that installs an LED lighting system, it may not be around for 50,000 hours. I mean, it may be out of business in a very short while, and it will never recoup the cost of the initial installation. That's quite different from something like a government building and so on. So I think that's another consideration. I mean, if you hit 50,000, you're great, but if you only end up at 800 hours, I think you've got an additional outlay that you have to keep.
Well, that's why we are also working very hard to lower the initial cost also. That's why I was talking about adopting this silicon technology to make the LEDs. Because once the volume gets high, and the silicon technology is very reliable, now you get, a laptop never goes down. I mean, those chips that run there, it can run for I don't know how many hours. It's a longer lifetime than your laptop. So we are adopting this silicon technology so that we can make the LED with the low manufacturing cost and the same lifetime and the same quality that can really last that long. So this is another thing that we are also trying to do.
Well, also, I'd like to add a little bit of additional thing. I mean, I'm advertising for myself. Our company is one of those who really started using LED lights in our jewelry, in lighting up our jewelries, about 8-9 years ago. And one of my colleagues is working here, is here today. Now, initially, I think the investment on these lightings were expensive, but I think that overall, over the years, the construction, the cost of these lights dropped considerably. But I think the biggest cost in saving is in the maintenance of those lights, because if you have 50 shops and you need to change light bulbs all the time, and they make orders, people will be running all over the places, changing light bulbs, because the people in the shop don't change it for you. But once when you set up lighting like that, the people that he hired, is no longer there. The people be working on something else instead of changing light bulbs. So this is another kind of additional cost that the professor, did not put into it, because she's an academic and I'm a business person. I look at cost in a different way. But I think these are some very, very beneficial thing about LED lightings. From what we are looking at.
Well, I mentioned the first use of a LED was the traffic light. That's the main reason, because the traffic light need to be on 24 hours, and then you cannot wait until the light bulb burns and then you go change it. So, and you also need to send out people in the middle of the night when there's a lightest traffic to change the light before they burn. So that's a light bulb, of course, it just have a few thousand hours lifetime, and then you need to change it every few months. So like you said, the labor cost is extremely high. So this is the reason why, even though initial LED traffic light was a high cost, and then people change it anyway because of the changing the light bulb, like you said.
Well, they'll be creating more unemployment this way.
Please. Professor Liu, how fast do you think the price is falling?
Very fast, just like the Moore's law. I have one of these here. It's, in fact, this, what I call this low-cost light bulb that we are trying to make is going to cost just a few dollars. Okay, it's getting there. It's getting close to the fluorescent light. It is going down. Once the volume goes up, and then the cost will go down. In fact, in many of the manufacturers, so this is what I'm showing, that the cost. This is the cost of the LED per lumen. So we just use the lumen as the unit. This cost per lumen is going down to in about year 2015, and it's actually cost close to a light bulb. A few more years, a couple more years.
Can I ask you a technical question?
Sure.
What is the density of light sources that you can put on the chip, and how big you can make these chips?
Well, for now, it depends on the yield. So what we are making in the lab, so the yield is not that great. So I can show you one of these, like this a demo that I'm showing that Hong Kong 科技大學 that is streaming through. So these are like 900 pixels, and then there's still 1 or 2 dead pixels. This is about a little less than 1 centimeter square, and we just cut them up. I mean, for a wafer, you can have a big wafer. And then if we get to like the silicon foundry, like I said, if we can get the same yield of a silicon foundry in making this, then the cost will be much, much lower, and we can make it much bigger.
The density of the light sources will also go up.
Yes. Yes, absolutely.
So are there manufacturers able to do that using your technology?
There are silicon foundry now, but right now there's no LED foundries. If you're interested in building one, then I can help you.
Professor,
Yes.
I think we all here, sitting here, we all support the idea of using LED. But I have an experience that I have an opportunity of doing 90 SME for the energy audit and advising them to change from the T8 to T5 and then to LED. The problem of these, we would like to save, like altogether this 90 SME would save 400 tonnage of the CO2. But the problem of these SME are delaying the change to the LED is because of the installation cost is expensive. Of course, it will take a while to earn back, as what Max just mentioned, that it will earn back the money in the initial expensive installation cost. But I'm thinking what the HKUST, perhaps you can do one step forward, is that how you're going to line up the commercial, or you can further develop how to really thinking into the reduce the installation cost, and so that we can, as a whole community, we should promote more about using the LED. And as a layman, because like what we can, nowadays you go into any supermarket, you can easily buy a light bulb. But we cannot find an LED in the supermarket. Again, this is something we have to work together. I mean, perhaps this is something for everybody sitting here, and also together with the university, we should think another way forward, because thinking about the environmental protection ahead of us, we have to do something.
Yes, I agree with you. But what I'm telling you now, the high cost of the installation, I'm sorry to say that because a lot of business people here, it's the middle people that are making the money. Actually, the LED chips now is very, very inexpensive. When I first came to Hong Kong in year 2000, one little tiny LED chips, if you buy it from this manufacturer called Cree, 70 cents US dollars. Now it's 7 cents renminbi. Yeah.
So do you see the potential of manufacturing really north of our border here, or should how do you see we can bring more of the manufacturing that is right next to us, so that we can harness this interesting.
We can do it right in Hong Kong. We have industrial parks. So we have a science park. We have in Yuen Long. We have in Taipo. Yeah. So we can do this right in Hong Kong.
Well, it's 3 more minutes to 2:15. Any other questions? May I have the last question then?
Yes.
More than a few years ago, I was traveling in a very remote part of China, and I saw these lampposts which has solar voltaic cells on it. Now, as a result of that, I noticed one thing was that they did not need a very expensive distribution system of power cables. Now, is there anybody thinking in terms of combining photovoltaic cells together with LED technology in order to light up the lamps, light up the roads at night, free from any kind of energy cost?
Yes. Yes. That's I show one of the pictures. It's when I went to China, Xihuang, that they have one there.
They already have it.
Yes, but the LED that they use is not very bright. So it's the technology. How do you combine the technology? You need to have a good efficiency when you combine that. You got to use a better efficiency or better quality of the LED, so that the people will feel, hey, this is not enough sunlight to drive it at night. Hey, this is an LED street lamp. It's so dim. Yeah, people are doing it.
Okay, thank you. So my idea is not an original one. Well, here I want to thank you, Professor, for bringing us using a very, very small light to tell us a very, very small thing about what's going to happen in the big future. And if there is anything that you find curious or you want to find more about it, well, please contact us or the university, and then we'll try to put the two together. Thank you very much. Thank you for coming.